Guys, for any piecewise function, it's usually when we do it's going to be like 2 or 3 functions or however many. But this is a continuous function. It's a line. You know what I'm saying, Amina? This is a continuous function. It's a line. If I want to know the limit value, you can just plug it in. Plug in that x value for anywhere where this is determined or this is determined. The only place you got to be careful about is where, Allie?
2.
Yeah, in this case, where they connect up. You know what I'm saying, Michelle? And if you're taking a piecewise of a couple continuous function, the limit is going to exist everywhere at 3 minus x. It's just a line, and it's equal to the function value. So you can just literally just plug the value in. Okay, does that make sense, Chris? The trick on how to solve, Magali, like if it connects up and everything, here's what you can do. If you plug in 2 into this function, it's kind of, even though it doesn't exist there, you can kind of see, okay, where does it go just, even though this is defined just to the left, if you plug in a 2, you can kind of see where it's going. It's kind of a cheat. You know what I'm saying? So if you plug 2 into this, what do you get? You get 1, and that's why this thing approaches 1. You see it? Even though it's not defined at 2, you can say, okay, where's it going? Where's it going to go at 2? This thing is going towards 1. Where's this thing going towards? Yeah, even though you're not supposed to plug in a 2, because that's not part of the function, Katie. But for all practical purposes, if I just want to know where this thing is going, as you approach 2 from the right, you just kind of plug it in. Does that make sense? And this thing approaches 2. If this approaches 1, and then approaches 2, what does that say about the limit as x approaches 2? Yeah, does that make sense? So either you can make a graph of it, and you can see that it's going to 2 different places, or use that as a little trick. You can always just plug in the value, okay? It's kind of a quick trick. Where's this function going? Where's this function going? Okay? And the same thing's true here. Everyone graph this one right here on your calculator. Sine x from negative to, just do x less than 0, do cos x for x greater than or equal to 0. Graph that piecewise function. That is number 49. You don't have to do just do x less than 0. So just do to the left of 0, it's this function. So x less than 0, and then this one, x greater or equal to 0. You've got to worry about the endpoints for the graph. But graph that piecewise. Let's answer some questions. Let me know when you guys are all good. Does everyone have it?
Wait, what is this?
So just do x less than 0 for the sine x one, and then x greater than or equal to for the cosine x function. So it's just there and there. And it'll just, those won't stop. So here's our piecewise defined function. Let's just ask some questions on it. Roxana, I want to know what's the limit as x approaches negative pi. Does it exist, and what's it equal to? Look either you can look up here if you want.
As x approaches negative
Yeah, as
pi.
x approaches negative pi, when does the limit exist, and what is it equal to? Bless you.
From the negative side, as x approaches negative pi, it's 0. And from the positive side, it's up.
So what does that mean?
The limit exists at 0.
Yeah, the limit exists is equal to 0. So again, from the left and the right is the same. Or since all of this here is just a continuous function, just plug in a negative pi into the sine function. Does that make sense? That's kind of the cheat around it. You can do it like a polynomial, like a line, a cubic, a quadratic, any of these trig functions, any exponential function. It's going to be continuum. So you can just plug in the value. Okay? What about, let's go at 0. So at 0, what's the limit as x approaches 0 from the left? 0. What's the limit as x approaches 0 from the right? 1. What does that mean about the limit at x equal as what does that mean about the limit as x approaches 0? Yeah, okay. What's the function value at 0? Yeah, what is cosine of 0? What's the x length of the reference triangle of 0 degrees?
1.
It's 1, okay? So limit doesn't exist. Well, do a little slight modification on your graph and change this. Change the sign to sine x plus 1. So, like this. Sine of, close parentheses, x plus 1, like that. Everything else is the same. Just add like a little, go second insert and just put a plus 1 and graph it. And does the limit exist at x equals 0 in this case? Do you think so? Well, what is the limit as x approaches 0 from the left in this case? What'd you say, Chris?
Do you mean like sine x plus 1 or sine x plus 1?
Sine of x plus 1. Yeah, don't put the x plus 1 in the parentheses. Sine of x plus 1, just like this. Yeah, otherwise it'll be off. Is it way off then? I see, then you're like, yeah. So what is the limit as x approaches 0 from the left? Any takers? What's the limit as x approaches 0 from the left? 1. What's the limit as x approaches 0 from the right?
1.
What does that mean about the limit at x equals 0?
1.
So in this case, the limit exists everywhere. Because to the left here, the sine of x plus 1, you can always just plug in the value. And then, ask your question.
So when I plug in x equals 0, it says y equals 0.
I don't know what that means. What do you mean you plugged in x equals 0?
No, like so you grab.
Oh, like the second trace and like calculate?
Yeah.
Check your table.
It's
Okay, Eve, you got it? You checking that out? Do some troubleshooting. Okay. So like, what you can do is, like, since you know the sine x you can plug in anywhere, and the limit's going to equal the function value. The cosine, the limit's going to exist everywhere. The limit's equal to the function value. The only place you have to check is where they connect up then. You know what I'm saying? If you're to have a piecewise of two continuous functions, the only thing you have to check is where they connect up. And here's what you would do. Again, even though this isn't defined at x equals 0, or in the case this one, you can still just plug it in. You know, kind of like, where is it going? Well, this thing would go, sine of 0 is 0 plus 1. This thing from the left approaches 1. What does this approach from the right? Well, just kind of plug in. You know, it's a cheat, Roxana. You know what I'm saying? You know, you can do the table, you can get really close, but if you want to know what it's approaching for a lot of these like piecewise defined, just kind of plug it in. In this case, it's also equal to 1. So they're approaching the same thing. So the limit's going to equal, it's going to exist everywhere in this function. Okay? Even though it's two weird little squiggles, one squiggling like this and one squiggling like this, they connect up. So the limit's going to exist everywhere. Okay? Any questions on that?